Today we will discuss about the system of linear equation. Before this, first we have to know about homogeneous and non-homogeneous system of linear equation. Let us consider an equation Ax is equal to B, where Ax and B are the matrix. X is matrix of variable as x, y, z. A is matrix of their coefficients, means coefficients of the variable, and B is a matrix of constant term. Now see here, if B is equal to 0, then this system is called homogeneous. Example is given here. These are the examples of homogeneous. If B is the matrix of constants are 0, 0. And in this system, if B is not equal to 0, in these examples, B 3, 5, 5, 6 not equal to 0, then the system is known as non-homogeneous. Okay, and linear means if degree of the variables are 1, 1, so it is known as linear equation. Now, there are two types of equations, solutions, system of equations, consistent and inconsistent. If its a solution exists, means solution of the given system exists, then we can say that our system is called consistent. Inconsistent, if solution does not exist, means system has no solution, then the system is called inconsistent. Now, how to find the solution of the linear equation by inverse method? Considering linear equations as a1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, a3x plus b3y plus c3z is equal to d3. So these are the linear equations, non-homogeneous. Why? Because B is not equal to 0. Here B is d1, d2, d3. Now you can form the matrix from these system of equations. A is matrix of coefficients of x, y, z written here. X is matrix of variable x, y, z, and B is matrix of constant d1, d2, d3. If A is non-singular means determinant A is not equal to 0, then A inverse exists, otherwise not. We can find the solution by using the relation Ax is equal to B, where x is A inverse B. Using this relation, find the solution of the system of equation by matrix method. System will be consistent if determinant A is not equal to 0, means it is non-singular, as a system having unique solution. It is consistent in this case. Now, case number second, if A is non-singular matrix, A is singular matrix, not non-singular. If A is singular matrix, that is determinant A is equal to 0, then we will find the value of adjoint of A into B. In second case, if A determinant A is equal to 0, means it is singular matrix. Find the value of adjoint of A into B. Now, if adjoint of A into B is not equal to 0, remember here this value is not equal to 0, then solution does not exist, means having no solution. And in this case, you can say that system is inconsistent, having no solution. Now, second part of this case, if adjoint of A into B is equal to 0, then system may be either consistent consistent means may have solution, or inconsistent means having no solution according as the system has many solution or no solution. So in this case, system may be either consistent or inconsistent. In second case, if A is singular matrix. Now, from examples, we can determine the solution of. Now see how to find the solution of the system of linear equation from the example. This is the example of three variables. First equation 2x minus 2y plus 3z is equal to 8. Second is 2x plus y minus z is equal to 1. And third is 4x minus 3y plus 2z is equal to 4. You can form the matrix A, matrix of coefficients from first equation 2 minus 2 3, right in first row. From second equation coefficient 2 1 minus 1, right in second row. And from third 4 minus 3 2, coefficient right in third row. Now x is matrix of the variable in column, B matrix of constant right in column, and apply this relation to find the solution. X is equal to A inverse B. Now, for A inverse, first you will determine the value of A, whether it is singular or non-singular. To find the determinant of A, solving this a matrix, find its determinant. Easily you can find how to expand. You know, after expanding, you will get minus 17. Determinant of A, which is not equal to 0, means it is non-singular matrix. Means solution exists. Other system will have unique solution. So for A inverse, first you will find the cofactors of these elements. From A matrix, cofactor of first C11 is minus 1, cofactor of second element 1 to third element, this is this, means find their cofactors. You can determine. Now form the cofactor matrix. This is the cofactor matrix C11, C12, C13, and find its transpose. Transpose of the cofactor matrix is adjoint of A. You know, adjoint of A means transpose of cofactor matrix. This is. Now putting their values of cofactors, adjoint A is this. Now A inverse is adjoint of A upon determinant A. Determinant A is, you have determined minus 17, and adjoint of A written here, this is. Then find A inverse into B. So A inverse into B, the value of A inverse is this into B, multiplying with B. And when you multiply first column, the value will come out minus 17. Now second row first column, why? Because there is only one column, first row first column, then second row first column, this is value minus 34, third row first column. After solving this value, you will get minus 51. Now apply this formula. X is equal to A inverse B, X, Y, Z in column is equal to A inverse B. The value is written here. Now multiplying by 1 by 17 with minus sign, you will get 1, 2, 3. So X, Y, Z is equal to 1, 2, 3. Now equating corresponding element, X is equal to 1, Y is equal to 2, and Z is equal to 3. This is the solution, unique solution. Why? Because A is non-singular matrix. Okay.